In this presentation, we're going to take a look at a set of points and we're going to determine whether or not those points are linear. So what I've created here is a table of 3 points. Those 3 points are 0, 7, 3, 4, and 4, 3. Now if I really wanted to, I could get a sheet of graph paper, plot those 3 points, and determine whether or not all 3 fall in the same line. However, I don't have graph paper. It's very difficult to make some that's perfectly straight, and it's just too much time. So I'd like to answer this question, whether or not these 3 sets of points are linear, without even graphing them. In order to determine if those points are linear, I need to know what linear means first. Points are linear if the slope between the points is constant. Suppose that I have the 2 points 1, 1 and 2, 3. The question is, in order to get from one point to the other, how much would I need to move up and then or down, and then how much would I need to move left or right? So if I were starting at the point 1, 1 and I wanted to get to the other point 2, 3, I would need to move up 2 places and then over 1 place. That is my slope. So the slope between 1, 1 and 2, 3 is up 2 over 1. Keep in mind that my slope is always moving up or down first in the numerator and moving left or right second in the denominator. Without my graph, how can I determine that the slope is 2 over 1? If I look at the y values, I can see that to get from 1 to 3, I would need to have to go up 2. And to look at the x values, I can see that to get from 1 to 2, I would have to go right 1. So, looking at those 2 values, 2 over 1, again, would give me my slope. So let's go back to our original set of points. Now I have 3 points listed here. So what I'd like to do is I'd like to find the slope between 0, 7 and 3, 4. So looking at 0, 7 to 3, 4, if I look at my y's, in order to get from 7 to 4, I would have to go down 3. In order to get from 0 in my x's to 3, I would have to go up 3. So the slope between those 2 points, remember to put our y over our x, is down 3 over right 3, which is the same thing as negative 1 over 1. So I know that the slope between 0, 7 and 3, 4 is negative 1 over 1. But now I need to check the slope between 3, 4 and 4, 3. That slope should be negative 1 over 1 if all 3 points are on the same line. So looking from 4 to 3 on my y values, I'm going down 1. And from 3 to 4 on my x values, I'm going up 1. So again, my slope, change in y over change in x, in this case is negative 1 over positive 1. So thinking back about the table, I know that the slope between the first 2 points was negative 3 over positive 3, or negative 1 over positive 1. I also know that the slope between the second 2 points was negative 1 over positive 1. Since both sets of points have a slope equal to negative 1, this table, these points, are, in fact, linear. Let's try another example. So now I have a new table and I'm trying to determine whether or not these points are linear. This is a table of 4 points. So now I'm going to have to find 3 different slopes. I'm going to have to find the slope between the first 2 points, and then the next 2, and then the last 2. So I'm quickly just going to take a look, and I'm going to look at all of my changes in y all at once. So 10 to 12 is up 2, 12 to 16 is plus 4, 16 to 22 is plus 6. Now I'm going to take a look at all of my changes in x. 0 to 1 is up 1, 1 to 3 is up 2, and 3 to 5 is up 2 also. So now looking at my slopes, the first slope is positive 2 over positive 1, which is 2 over 1. The next slope is positive 4 over positive 2, which is also equal to 2 over 1. So this is looking good because both slopes are the same. They're both 2 over 1. Now looking at the last 2 points, now I have positive 6 over positive 2. Oh, that's no good. I've got a slope of 3 over 1. That last point is a steeper slope than either of the other two. I would conclude with this table that the points are not linear.